Have you ever paused for a moment, truly considered what makes it possible for you to effortlessly access those shared documents at work, or stream that massive video file from a central server without a single hiccup? It's become so commonplace, so fundamental to our daily digital lives that we often take the underlying magic completely for granted. But behind the scenes, there's this fascinating, intricate world of digital information storage and hidden complexities that work tirelessly to make it all just work. Today we're taking a deep dive into network-attached storage, or NAS, what it is, what makes it tick, and why it's such a fundamental game changer for so many organizations, from agile startups to sprawling enterprises in our increasingly digital world.
You've hit on such a critical point. Information isn't just important in our daily lives, it's become absolutely foundational to how we operate. We truly live in an on-demand world, right? Where the expectation is to access information precisely when and where we need it, without delay. Think about the sheer volume of data being generated every second. We're constantly online, engaging in social networking, sending emails, collaborating on documents, sharing high-resolution photos and videos, and using countless applications, for both work and personal life. And, perhaps surprisingly to some, a growing proportion of this content, like your personal photo archives or those high-definition family videos, is actually created by individuals, not just large corporations.
Right, it's not just business data anymore.
Exactly. And while much of that information starts locally on devices like phones, tablets, or laptops, its true utility and value only really emerge when it can be shared, collaborated on, and accessed from anywhere. To facilitate that sharing and to provide the necessary resilience and scale, this data needs to be uploaded to central repositories, what we commonly call data centers, via robust networks. And that brings us directly to the core challenge. How do we share all that information effectively, efficiently, and securely?
And that's exactly our mission today. We're going to unpack the core components and the undeniable transformative benefits of NAS, one fascinating detail at a time, just for you, the curious learner who wants a shortcut to being truly well-informed on this essential technology. So, okay, let's unpack this. Let's cast our minds back a bit, maybe before the era of ubiquitous high-speed network connectivity and centralized storage. Think about how we used to share files, especially in a business context. You'd copy something to a floppy disk. Remember those?
Oh, I remember them well. Maybe too well.
Huh. Then perhaps a CD, or later a DVD, or if you were really cutting edge, a USB flash drive. It seems almost quaint now, a relic from a bygone era, doesn't it? I remember a time when our office would literally pass around a USB drive like a hot potato, praying it wasn't infected or lost somewhere between desks.
Definitely been there.
But this reliance on physical, portable media highlighted a massive, almost crippling problem for businesses. How on earth do you share a critical document across different departments, across different office locations, perhaps even across continents? And what about sharing it with a large number of users who all need simultaneous access to the same file? You simply can't pass around a USB drive to 100 people and expect any semblance of efficiency or consistency.
You've perfectly captured the pre-network headache. That physical media problem was indeed just one symptom of a much larger systemic challenge. Even as networks evolved, traditional approaches to network-based file sharing often involved deploying a multitude of individual file servers. Imagine a large company with perhaps hundreds or even thousands of employees, where each department, or sometimes even each individual work group, managed its own dedicated file server. This approach inevitably led to what we vividly describe as islands of data.
Islands of data, I like that term. It paints a picture.
It really does. You'd have some servers that were perpetually overutilized, constantly running out of disk space or bogged down with too many concurrent user requests. Meanwhile, other servers sat largely idle and underutilized, just wasting valuable resources and capital. This fractured, disparate approach created significant, agonizing issues across the board. First, poor scalability.
Right. Adding more storage is probably a nightmare.
A total nightmare. It became a cumbersome, inefficient, and often disruptive process. Second, management costs became astronomically high because IT teams were forced to administer countless individual systems, each with its own quirks, patching cycles, and troubleshooting demands. And third, there was a tremendous increase in overall operational complexity, leading to an environment that was a true logistical and operational nightmare to manage all those disparate pieces. It was a constant game of digital whack-a-mole, and it consumed valuable IT resources that could have been dedicated to innovation.
Wow, islands of data truly paints a picture of chaos and inefficiency. So if businesses were struggling with this kind of fragmented setup, what was the biggest frustration you'd hear from IT managers trying to scale their operations or just keep things running smoothly?
The biggest frustration was undoubtedly the constant firefighting and the inability to scale proactively. IT managers were always reacting to a disk full alert here, a performance bottleneck there, rather than planning strategically.
Reactive instead of proactive.
Exactly, because this growing, undeniable challenge, this proliferation of isolated data islands, really created a vacuum for a truly dedicated solution.
And that's where network attached storage, or NAS, stepped onto the scene. It emerged as an elegant, purpose-built solution, specifically designed to consolidate these scattered resources and tackle these very issues head-on, offering a far more efficient, scalable, and manageable way to handle shared file data. It represented a fundamental, almost revolutionary shift in how organizations thought about and managed their burgeoning digital information.
NAS truly arrived as that dedicated solution. At its core, NAS is exactly what its name implies. A dedicated high-performance device engineered specifically for file sharing and storage directly over a standard IP network. You can think of it as a highly specialized server, meticulously optimized for the sole purpose of serving files quickly and efficiently to many clients simultaneously.
So not like a general-purpose server doing a million things at once.
Precisely. Unlike a general-purpose server that might run a multitude of applications, databases, and file services all at once, a NAS device is singularly focused on delivering file data. This specialization is absolutely key to its exceptional performance, its streamlined management, and its inherent simplicity in a complex IT landscape. It's built for one job, and it does it exceptionally well.
So if a NAS device is so good at its job,
Yeah.
what exactly is inside it that makes it so effective? As instructors today, we're sort of breaking it down. We're talking about two main players here working in concert that enable this specialization, the NAS head and the storage itself. The NAS head is essentially the brain of the operation. It's a dedicated file server, but it's not just any server. It often runs its own proprietary operating system and a specialized file system that are fine-tuned for the demanding task of file serving.
Optimized, yeah.
Right. That optimization means it's incredibly efficient at handling file requests. This head connects to the broader IP network via what we call front-end Ethernet ports. These are the crucial gateways through which it receives and handles all those incoming client requests for files, whether you're trying to open a Word document, edit a Photoshop file, or stream a video.
Okay, so the head is the server part facing the users, the network.
Exactly. But a brain needs memory, right? Or in this case, storage capacity. And that's where the actual storage comes in. The NAS head connects to the storage, which can be either internal to the NAS device itself, meaning the hard drives are built right into the appliance.
Like an all-in-one box.
Yeah, or external, residing in separate dedicated storage arrays. This connection often happens through a storage controller utilizing high-speed, dedicated connections like Fiber Channel or FC.
Or FCOE these days, too.
And its evolution, Fiber Channel over Ethernet, FCOE. Exactly. Think of these as superhighways designed specifically for data, far faster and more efficient for storage traffic than your regular internet connection. They're built for the high-volume, low-latency demands of storage.
Makes sense. Need that speed for storage.
The magic then happens with what we call LUNs, or logical unit numbers. Imagine your massive external storage system as a giant warehouse full of books. LUNs are like specific predefined sections or shelves that are virtually presented to the NAS head.
So it carves up the big storage pool.
Precisely. The NAS head then sees these sections not as abstract parts of a warehouse, but as if they were its own dedicated physical hard drives, ready to organize, configure file systems upon, and then, crucially, share those file systems out to the network.
And that last point really highlights the network part of network-attached storage, making it truly powerful. Crucially, NAS relies on standard network and file sharing protocols. We're talking about TCP/IP for the actual data transfer, ensuring that data packets get from point A to point B across the network reliably and efficiently.
The basic internet language.
The foundation, yeah. But then, on top of TCP/IP, it uses specific file service protocols. These are the languages that allow different operating systems to communicate seamlessly about files. The two big ones are Common Internet File System, or CIFS, and Network File System, NFS.
CIFS and NFS.
Got it. This is what enables seamless file sharing, whether you're a UNIX user accessing a file from a powerful workstation or a Microsoft Windows user on a laptop in a different office. It elegantly bridges those traditionally separate worlds, allowing everyone to access the same centralized file data without compatibility issues or needing special software. That's a truly powerful capability for any organization with diverse computing environments, which is, let's face it, almost every organization today.
We've painted a clear picture of the historical headaches and the core architecture of NAS, the components, the protocols. But let's get down to brass tacks. Beyond the technical specifications, what's the tangible upside for you and your organization? What does NAS truly bring to the table that those antiquated methods, those frustrating islands of data, or even just shuffling physical media simply couldn't deliver? It boils down to some pretty profound advantages, right? Advantages that have revolutionized how businesses manage their digital assets.
Absolutely. There are three main benefits that truly make NAS a game changer in modern IT environments, solving those historical pain points you mentioned. And these are key takeaways for anyone learning about NAS. First, it offers simplified management.
Ah, the whack-a-mole problem solver.
Exactly. Imagine an IT administrator trying to keep track of 100 different individual file servers, each with its own unique configurations, its own quirks, its own updates, and its own potential points of failure scattered across various departments. It's a never-ending game, constantly reacting to issues. NAS fundamentally changes that. Instead of wrestling with potentially dozens or even hundreds of individual file servers, each with its own storage and access controls, NAS provides a centralized console.
One place to rule them all, so to speak.
Kind of, yeah. This allows for incredibly efficient management of your entire file system structure and all your access permissions from a single intuitive point. It's like going from managing a sprawling, unorganized city block by block to overseeing a perfectly integrated smart home. Everything is visible and controllable from one dashboard. This doesn't just save countless hours of administrative overhead and dramatically reduce complexity. It liberates valuable IT teams to focus on strategic initiatives and innovation rather than just firefighting day in and day out.
Okay, simplified management. That's huge. What's next?
Second, NAS delivers exceptional scalability. Remember those islands of data where you'd constantly run out of space on one server while another sat idle?
Yeah, the feast or famine scenario.
NAS eradicates that problem. Its high-performance, low-latency design means it can handle a wide variety of utilization profiles and different types of business applications without breaking a sweat. Whether your data needs are growing incrementally, perhaps a few terabytes a month, or experiencing sudden, massive bursts of demand like a media company suddenly needing to store petabytes of new video footage, NAS is designed to grow right along with your needs. Need more space? You simply add more disks or disk shelves to the central NAS unit. Need more performance for a demanding application, perhaps one that requires extremely fast read-write speeds?
Like video editing or something.
Exactly. You can often add more processing power, higher speed drives like solid-state drives, or even additional NAS heads. It's built to adapt and expand both capacity and performance, often without downtime.
So it grows with the business. Makes sense. And the third benefit.
And third, and perhaps most critical for ensuring continuous business operations, is its high availability. Downtime for file access can mean lost productivity, lost revenue, and damaged reputation. NAS offers efficient replication and recovery options, which directly translates to ensuring your data is always accessible, even in the face of hardware failures.
Keeping the lights on, digitally speaking.
You got it. It achieves this through the pervasive use of redundant components throughout the system, meaning if one power supply fails, there's another ready to take over. If one network card goes down, there's a backup. This maximizes connectivity to your data. Beyond component redundancy, many NAS devices also support sophisticated clustering technology for automatic failover. This means if an entire NAS head or a critical component goes offline unexpectedly, another unit in the cluster can automatically take over its operations, seamlessly and with minimal, if any, disruption to your users.
So the users might not even know something failed.
They might not even notice a glitch, simply continuing to access their files as if nothing happened. This level of resilience is paramount for modern businesses that simply cannot afford downtime.
That's a huge shift, isn't it? Moving from those fragile, isolated islands of data we talked about earlier, where a single point of failure could halt operations, to a consolidated, resilient, and remarkably manageable hub for all your shared files. It's truly a shortcut to being well-informed about modern data management, showcasing how purpose-built solutions can dramatically improve efficiency, reliability, and ultimately the bottom line for any organization.
Definitely. And to truly appreciate how NAS enables this seamless sharing across diverse operating systems, allowing your Windows laptop and a Linux server to both access the same central file, we need to dive a bit deeper into those two primary file sharing protocols it leverages, CIFS and
Right,
NFS.
the languages the files speak.
These are the actual languages files use to travel across the network. Let's start with CIFS. This is a client-server application protocol designed specifically for remote file and service requests over TCP/IP, the foundational internet protocol. It's essentially a public, open variation of the server message block, or SMB protocol, which you might be more familiar with from Windows networking.
Okay, so CIFS is related to SMB, the Windows thing.
Exactly. CIFS includes crucial features to ensure data integrity and prevent conflicts, especially when multiple users are accessing the same files simultaneously. For instance, it uses sophisticated file and record locking to prevent users from accidentally overwriting each other's work on a file, or even within a specific record in that file, ensuring consistency.
Stops people saving over each other's changes.
Pretty much. It also supports fault tolerance, meaning if there's a temporary network interruption or even a CIFS server failure, it can automatically attempt to restore connections and reopen files that were in use. However, this relies on the application itself being designed to take advantage of these features. CIFS is considered a stateful protocol.
Stateful. What does that mean exactly?
It means the CIFS server actively maintains connection information or state for each client that's currently connected and has files open. It remembers who you are and what you're doing. If a network failure or server failure occurs, the client receives a disconnection notification, and user disruption is minimized if the application has the embedded intelligence to reestablish that connection and pick up where it left off. Otherwise, the user might need to manually intervene. From a user perspective, it's incredibly friendly, utilizing that easy-to-understand naming scheme you often see, server share or servername.domain.suffix share.
Ah, the familiar / path.
That's the one. Makes it intuitive to browse and connect. Then there's NFS, or Network File System. This is also a client-server protocol for file sharing, but it's most commonly used in Unix-based systems like Linux, macOS, and other Unix variants.
So NFS is more for the Linux and Unix world?
Traditionally, yes. Originally, NFS was built on the Connectionless User Datagram Protocol, or UDP, for sheer speed, prioritizing quick transfers over guaranteed delivery in every single packet. However, modern versions also heavily use TCP for greater reliability, particularly for larger file transfers. It employs a machine-independent model to represent user data and relies on Remote Procedure Call, or RPC, for inter-process communication between two computers, essentially allowing a client to make requests to access files on a remote system as if they were local.
Okay, uses RPC. Got it.
Now, here's a crucial distinction we need to make as instructors here. Earlier versions, specifically NFS v2 and NFS v3, are stateless protocols.
Stateless, so the opposite of CIFS.
Exactly the opposite. Think of it this way. With a stateless protocol, every single request from the client to the server is entirely self-contained. It's like sending a postcard where you write the full address and message every single time, even if you just sent one 5 minutes ago. The server doesn't remember who you are from the last interaction. It simply processes each request independently. This design makes these NFS versions incredibly resilient to server crashes. If the server suddenly goes offline and comes back, it hasn't lost any memory of ongoing connections because it never had any.
So it just picks right back up.
It just picks up processing new requests immediately without needing to rebuild connection states. However, this also means the client has to manage more of the connection intelligence. On the other hand, NFS version 4 and its later enhancement 4.1 introduced a significant shift, adopting a stateful design similar to CIS. This brought enhanced security features and new capabilities like session models and parallel NFS to offer a more integrated, higher performance, and more secure experience for modern workloads.
Okay, so NFS evolved towards being stateful too, like CIFS, in later versions.
Correct. Offering more features but maybe slightly different recovery characteristics than the older stateless versions.
So whether you're working in a predominantly Windows shop, a Unix-centric environment, or, as is often the case in today's increasingly heterogeneous IT landscapes, a seamless mix of both, NAS provides that essential bridge. It handles all that complex translation between these different operating system demands thanks to these foundational protocols CIFS and NFS. The end result is that your users simply get seamless access to their files without needing to worry about the underlying technical differences or compatibility issues. It truly simplifies what could otherwise be a compatibility nightmare, ensuring everyone speaks the same language when it comes to shared data.
Could have said it better myself. It's all about that seamless access.
Now, NAS isn't just one thing, right? Not a single monolithic solution that fits every organization. It actually comes in a few distinct flavors or implementation models, each designed to meet different organizational needs, scales, and budget constraints. Let's explore these common implementations: unified, gateway, and scale-out. Each has its own unique strengths, allowing organizations to pick what's perfectly tailored for their specific environment and evolving requirements.
Absolutely. Understanding these models is absolutely key to appreciating the true versatility and adaptability of NAS in various enterprise scenarios. Let's break them down. First, we have unified NAS.
Unified sounds like it brings things together.
Precisely. This implementation is all about consolidation and simplicity. Unified NAS effectively combines both NAS-based, which is file-level access typically used by end users for documents and media, and SAN-based, which is block-level data access primarily used by applications and databases for higher performance, raw data storage, all within a single integrated storage platform.
Okay, so file and block access from the same box.
Exactly. This means it supports CIFS and NFS protocols for file access, but simultaneously it supports ISCSI and fiber channel protocols for block access. The significant advantage here is a truly unified management interface. You're administering both types of storage, file, and block from one single console. This dramatically reduces your infrastructure complexity and management costs because you don't need separate teams or separate systems for each. A unified NAS system contains one or more NAS heads and the physical storage within a single system, often a single appliance. These NAS heads are connected to internal storage controllers, which then provide access to the physical drives. These drives can be a mix of different types, like traditional SAS drives for general purpose, high-capacity ATA drives for archival storage, or high-performance fiber channel and flash drives for demanding workloads, all tailored to different performance and capacity requirements within that single platform.
Okay, so unified is a versatile all-rounder, good for consolidation. What about gateway NAS?
Right, next there's gateway NAS. Think of this as a NAS head that utilizes external and independently managed storage. This is a crucial distinction from unified NAS.
So the storage isn't inside the NAS box itself.
Correct. Unlike unified NAS, the actual physical storage isn't built into the NAS head appliance itself. Instead, the NAS heads connect to existing, often high-end, storage area networks, or SANs. Imagine a large enterprise that already has a significant investment in a high-performance SAN infrastructure for their databases and applications. A gateway NAS allows them to leverage that existing storage for their file data without having to buy entirely new, dedicated storage arrays.
So it connects to the SAN they already have.
Precisely. This separation allows for much greater flexibility and extreme scalability. You can add NAS heads independently to scale performance, meaning if your file access demands increase, you just add more NAS gateways. And you can scale the underlying storage independently on the SAN side by adding more arrays or capacity to your existing SAN.
So scale performance and capacity separately.
You got it. While it offers higher scalability and leverages existing investments, the trade-off is often more complex management, as you're now administering the NAS heads and the SAN storage as separate, though interconnected entities. Communication between the gateway NAS heads and the external storage is typically achieved through high-speed fiber channel SAN connections.
Okay, gateway leverages existing SANs, offers independent scaling, but maybe more complex management. What's the third type?
Finally, we have scale-out NAS. This is designed for environments where data growth and performance demands are truly massive, often unstructured and highly unpredictable. Think of a massive media company managing petabytes of video files, or a research institution dealing with colossal data sets from scientific simulations, or perhaps a large cloud provider.
The really big data players.
Exactly. Instead of having one giant storage box or a fixed number of gateways, scale-out NAS operates like a hive mind of interconnected storage nodes, all working together as a single logical file system. Data isn't just stored on a single set of disks. It's intelligently divided and allocated across multiple nodes in parallel.
Distributed across many machines.
Right. When a client requests a file, the system is smart enough to retrieve the appropriate pieces or blocks from all those different nodes simultaneously, reassemble them lightning fast, and present the complete file to the client. The real power here is that as you add more nodes to the cluster, the entire file system dynamically grows, and data is automatically and evenly redistributed across all nodes. This boosts not just the aggregate storage capacity, but also the memory, CPU power, and network capacity of the entire cluster, linearly scaling performance as you add more resources.
So adding a node adds capacity and speed.
Yes, it's like adding more lanes and more cars to an ever-expanding superhighway as traffic increases, ensuring bottlenecks are almost non-existent. It uses separate internal and external networks. An internal high-throughput, low-latency network like InfiniBand or Gigabit Ethernet for lightning-fast intercluster communication between the nodes.
For the nodes to talk to each other quickly.
And an external Ethernet network for client access to the file data. This architecture is built for petabyte-scale data and extreme performance.
So you have a spectrum of choices. From an all-in-one unified system that intelligently brings file and block storage together for cost and management consolidation, to a gateway system that leverages existing high-end storage infrastructure, all the way to a highly distributed, performance-driven scale-out cluster built for massive data growth and extreme demands. Each with its own unique strengths, allowing organizations to select the implementation model that's perfectly tailored for their specific needs, whether it's optimizing existing investments, achieving ultimate scalability, or, a blend of both.
Well put. And beyond just understanding what NAS is and its fundamental architecture, it's vital to grasp its practical applications and how it's evolving with advanced features like file-level virtualization to solve even more complex data management challenges.
Okay, so where does NAS really shine in practice? What are the big use cases?
One of the most significant practical applications of NAS, which directly addresses those islands of data we discussed earlier, is for server and storage consolidation. Traditionally, UNIX and Microsoft Windows file systems often resided on entirely separate physical servers, requiring distinct maintenance schedules, patching cycles, and resource allocation. This led to fragmented environments, duplicated efforts, and incredibly inefficient use of valuable IT resources.
Back to the management headache again.
Exactly. NAS fundamentally changes this paradigm. By implementing a NAS solution, both Windows and UNIX file structures can be housed together within a single unified system. Crucially, the NAS system maintains the integrity of both file systems and allows access via their native protocols, NFS for UNIX Linux clients and CISSMB for Windows clients. This centralizes resources, dramatically simplifies management, and ensures that data integrity and security structures are maintained as long as the applications understand the data structures presented. It's a powerful way to reduce the number of discrete servers you need to manage, leading to lower power consumption, reduced cooling costs, and a smaller physical footprint in the data center.
Consolidation is definitely a key theme. What else? You mentioned file virtualization. That sounds interesting.
It is. Another fascinating and truly transformative capability, especially in environments with multiple file servers or NAS devices, is file-level virtualization. Imagine needing to move large amounts of file data from one storage device to another. Perhaps you're migrating to newer, faster hardware, or optimizing storage costs by moving older, less access data to cheaper storage tiers, or maybe just doing hardware refreshes. In traditional setups, this could be a highly disruptive, complex, and incredibly time-consuming process, often requiring downtime for users to ensure data integrity during the migration.
Yeah, nobody likes downtime for file access.
Nobody. File-level virtualization tackles this challenge head-on. It elegantly eliminates the dependency between the file's logical access path, that is, how you, the user, perceive the file's location through its familiar path name, like company share projects report.docs, and its actual physical storage location on a specific disk or NAS device.
So it separates the name from the physical place.
Exactly. It achieves this by creating a logical pool of storage, abstracting the physical location, and then using what's called a global namespace to map those logical, user-friendly paths to their true physical storage locations.
Okay, and here's where it gets truly transformative for you, the user, and for IT administrators. This enables non-disruptive file mobility. What that means, in practical terms, is that you can move files between different NAS devices or even different file servers, even while clients are actively accessing those files.
Bingo! That's the magic.
The clients themselves, the users, don't even realize the physical location of the file has changed. From their perspective, the file path remains constant, their applications continue to function without interruption, and they simply go on with their work, blissfully unaware of the complex data migration happening seamlessly in the background. That's a huge leap in operational flexibility.
Exactly. This capability of file-level virtualization simplifies file mobility immensely. It provides crucial user and application independence from where the files are physically stored. This means administrators can migrate vast amounts of data, think terabytes or even petabytes of files across online file servers or NAS devices without any interruption to the end users. Clients can literally be reading their files from the old physical location one moment and writing them back to what has become the new physical location the next, all without ever being aware that the physical storage infrastructure underneath has changed. This is a monumental leap in operational flexibility and efficiency for managing ever-growing file data. It means less downtime, fewer help desk tickets, and more agile data management strategies for businesses.
So what does this all mean for you, our curious listener? We've taken a pretty deep dive into network-attached storage today. We've explored its fundamental components like the NAS head and the underlying storage, and really understood the incredible benefits it offers in terms of simplified management, remarkable scalability, and high availability. We've also unpacked the crucial network and file sharing protocols like CIFS and NFS that make it all work seamlessly, allowing both Windows and Unix users to access shared data with ease, bridging those once separate worlds.
And we haven't stopped there. We've seen how different NAS implementations, unified, gateway, and scale-out are tailored to address diverse organizational needs, from consolidating both block and file access within a single platform to leveraging existing SAN investments or distributing data across a massive cluster for unparalleled performance and growth. Furthermore, we touch upon how innovations like file-level virtualization are fundamentally transforming how we manage and access our ever-growing mountain of digital data, offering seamless consolidation and, perhaps most impressively, non-disruptive file mobility that keeps businesses running without a hitch.
Next time you effortlessly access a shared document, stream a video from a corporate server, or pull up a presentation from a centralized repository, take a moment to consider the intricate yet incredibly robust architecture of network-attached storage working silently behind the scenes. It truly is the unsung hero of our information-dependent world. This kind of dedicated simplification, taking something incredibly complex and making it seem effortless, is a powerful concept. How might this kind of elegant behind-the-scenes engineering transform other complex areas of your daily digital life beyond just files, making the challenging seem simple and the impossible, well, commonplace?